Hello, hello, good mornings. Hello. Okay, so okay, good mornings. My name is Johnson Yaps. I'm the application engineer from CADVision. I'm the instructor for the webinar. I'm the presenter of the webinar session today. Actually, my webinar topic is practical modeling approach with weldments and sheet metals. Okay, if all is already comes and now it's 10 o'clock already, now I will start the webinar sections. Okay, again, my name is Johnson. Okay, so now I will start my webinar sections. If you have any questions, you can click the chat box here and inside the webinar's applications, and then I can receive it and I will answer you one by one. Okay, so now I start my topics today. Okay, for what is practical modeling approach with weldments and sheet metals in SolidWorks. Actually, inside SolidWorks, if you notice there is some convenience functions to build sheet metals 3D models and weldments 3D models. You see here, inside the top views of the SolidWorks interface, there is a sheet metals and the weldments tabs here. If you are notice. Okay, so now I will show you where is it. Okay, I will seem like this SolidWorks interface. You notice that there are sheet metals and the weldments tab here, and you see that some of the people do know how to use it and even do know what is the function inside this tab. So my topics today is to introduce to use how to use these two tab functions to build up the models. Okay, the weldments tab is in order to build the weldments components easily. Let's say this is the weldments component, the tables. You'll see the tables here. That's built of the square tubes. Okay, let's imagine if I use the normal methods, extrude it. Let's say I use this one, top plans, and then I build a square tubes. Let's say this is a square tube sketch, and then I just extrude it. You'll see here, I use the normal extrude methods. It will waste me a lot of time if I want to build a structure like this. Okay, so this come out the weldments and the sheet metal functions. It's a very convenient tool. We just need to draw a line, and then the weldments will follow the lines and help us in the shortest time to complete the weldment 3D models. Well, I discussed about the sheet metals. I give the example of sheet metal. Like this is a sheet metals. If you use the normal metal this is a sheet metal like the computer's casing. You see the computer casing is built by the sheet metals. It just bend it into the square sheet. Okay, I'll see these sheet metals. If I use the normal 3D practice, I have to make a very tiny, very thin sheet, the profile, and then extrude it. But if I use the sheet metal function here, I can do it very fast. I just need to drag it and then set the thickness, even insert some of the forming tool inside. Okay, so this is the convenience of the sheet metals and the weldments functions. So I will show you step by step how I use weldments function and sheet metal function to construct my 3D models. Okay, so now let's start it. Now I start from the weldments first. Okay, for this one, I just close it first. Okay, so now I jump back to my slide. Okay, so today agendas I will cover the beginning half section. I will cover the weldment, how to construct weldments 3D models even I make the shop drawings with the weldment, have the cut list and call out the weld tables. For the last half sessions, I will discuss about the sheet metal function. In this sections, I will build out the sheet metal 3D models, and then I will be by using the sheet metal functions, and then I will call out the bend tables inside the shop drawings. Okay, so now let's jump to the weldments section first. The first section, weldments. Our case is I want to build out the table, just now the table, with the square tubes, 2 times 2 inch square tubes. Okay, now let's just start the 3D model first. Okay, I close all first. I start the new parts. Okay, for the weldments functions, what I do is we just need to draw out the skeletons of the weldments part structure, weldments frame first. Let's draw the skeleton first. And you see that the skeleton we just draw by using the line on it. Let's say I use a top lens. Okay, let's say I draw the plate of the top part of the table. I give the dimension with 2000 meters weight height, the weight wide, and the 1000 weight. This is the size of the size of the table, and then I make the two skeletons, the two frame connecting the middle parts, because in order to strengthen the structure. And then I just simply make them symmetries and then give the dimension to it to complete this skeleton. Okay, make it at 500. Okay, I will see here the top part is okay already. Now I will jump to the sketch for the leg part, the leg of the tables. So here I will prefer using the 3D sketch. Let's say the 3D sketch here, because if I'm not using the 3D sketch, I have to build two plans here and then draw the line. So I better use the 3D sketch is better. So now I just draw 4 lines here. Now you see, it's very fast. The skeletons of the table is come out already. Now I just redefine it. Let's say these 2 points, let's say along that axis, so that I move it. Another will also follow it. For this one along x-axis, and this one along z-axis. This is just the constraint. Set the constraint to them. Okay, so when I move one of the legs, the other one will also move. So that now I just need to dimension one of it. Let's say I give dimension of 600, or maybe around 60 cm height. Done. Okay, I see the skeletons of the table is done. Now what I do is I just need to use the weldments tab here, and then click the structural member to add the structural member onto the sketching. I'll see here actually this function almost same as strip, but this is a very intelligent strip. We just need to choose the standard here. Actually, you can add your own library here. Let's say this library NSI inch standards. The type I can choose angle irons, C channels, pipes, rectangular tubes, or some others. In this case, I choose square tubes with the size of 2 times 2 inch with 0.25 inch thickness. Actually, this is a library. You can create your own library. Okay, if you want to create your own library and don't know how to create, you can call me. Later at the end of these sections, I will give you my phone number. Okay, I'll choose the structure member size already. So now I just need to click the line, and then the structure member will come out. Actually, you see that actually it's a strip feature, but this is a very intelligent strip. You see, I just double click all the line, and then you automatically have the structure member here. Even I can choose what corner I want, which type of corner I want. Okay, so I add a new groups. This new group is for these 2 structure member. You see, and then I add the more new group for the leg. Quite easy, is it? Just few steps we can construct all this out, and then I just click OK. and then the frame of the table is already come out. What I need to do is I just need to hide the sketching right here. Okay, I see that the structural member, the skeletons, the structural frame of the table come out very easily. Just imagine if I use the normal practice, how much time you have to spend in order to do these 3D models. Okay, now I continue. I want to make the flat plate at the bottom of each leg. So here, I just need to do the same. Because this is a flat plate, it's not a structural member. So I just need to draw by using the normal practice. Let's say this I make at a 100 mm square. Let them equal. Okay, I will see here I use the normal methods to construct this plate. Okay, then I leader patterns to another three legs. Okay, I just simply do this. I linear this to 2000 and then make this to 1000. Okay, start. See here. Now I want to make the weldings to weld this structure frame to the base plate. So inside the weldment here, there is a function called weld bit. We click and then we just click the line, and then you see that the welding will come out. I just make it all around. Then the welding is come out. Even I can choose the radius of the weld bit. Let's say make a new path at here. This leg. Make another new path at each leg. Let's say I make this leg. I make a new path at this leg. Okay, now you see that the weldments will come out. Even the weld symbol will come out. The weld symbol with 5 mm welding. Okay, so now I will add the materials. Let's say give it alloy steels, and my 3D model is done. Okay, seems that my 3D models is done. Now I want to make the short drawings to these 3D models. So let's do it. I just save it, and then I make the I see there's a new part, news table, and then I just make the drawing from it. Same like the normal practice. Make the drawing from this part. Oh, sorry. Before I make the drawings, I want to update my card list first. Okay, let's make this. Later I will tell you why I want to do this. Okay, so let's do it. Let's draw the drawings. Make the drawings for it. Okay, now let's choose the front and the top views, side views. I don't draw. Sorry. Actually, the front view is this. The 3 side views. Now we are here. Top views, right views, even I choose the diametric view for my study. Okay, for this one, I just enlarge it 110, and this one I also give it 110. Okay, for these ones I give it color views, and this one I give it hidden line view, so that I can see the hidden line here. Okay, the next step is I want to insert the dimension into it. So now I insert dimension to all of the view. Okay, the dimension first, all dimension come up. Wow. Okay, so all the dimension is come up. I select them and then allow the software to arrange them well. Okay, I will see here the weld bit symbol will also come up. Now let's also insert the weld symbol inside. Okay, this time I insert for this wheel I insert the weld symbol. You see the weld symbol will come up. This is only available for Weldments features. If you use the normal practice like the 3D drawing and 3D normal 3D or 3D features, but you are not using the Weldments features functions to do these 3D models, you cannot call out the welding symbols. Even you cannot call out these symbols. Okay, so now come up important time that I want to create an automated cut list. Let's say actually we can insert the cut list at here. At the insert pull down menus tables inside here have the Weldment cut list. If I choose these models, then my cut list will jump up. You see here, this is the cut list. Let's say I insert. Where are these? Maybe I want first. I just fix my covers. Now I just insert again the diametric views. Okay, done. So nice. Okay, now I will see here. Now I continue this. Now I insert the Weldments cut list for this 3D models, and then I insert the auto balance to this wheel. Yeah. Cancel first. I insert for this wheel. I insert auto balance. Okay, it's done. I will see the auto balance will automatically detect to the cut list. Let's say this 4 is encoding the 4, item number 4, and then here square tubes with the length of 574.6 mm, the quantity of 4, which is the frame of the 4 leg. So I can very easy to synchronize the Weldments cut list with the auto balance. The last thing for the Weldment is I want to mix the weld tables. So as inside the same table option here, we have the weld table. Let's click here, and then the weld table will come up. And this weld table seems that the quantity of 4 at here, at this place. Okay. So this is how we mix the Weldments shop drawings by using the SolidWorks. I only use around few minutes in order to construct from the 3Ds until the shop drawings. Is a very convenient tool for us. Okay, so now let's jump to the another half, which is the sheet metals. Okay, the sheet metal as same as the Weldment just now, we also can build it very fast by using the sheet metals methods. At here, at the final outcome of this webinar, I will make the sheet metal of the computer casings with the CADVision logo, events at openings and the leeward here. Okay, so now let me make the 3D model first. I just close the Weldments first. Okay. And then now I will start to mix. I will start to make a new part file first. Okay, so now I just click activate the sheet metals tab first. Now I use the top plans to make the base flange first. Base sheet metal. Every sheet metal product we will have a base sheet metal. which is the base for them to bend it. And then now I just build a normal rectangle first with the length of 700 and the height and the width of I'll give it 300. Okay, seems that it's already done. The sketchings, if I'm using the normal practice, I have to make a very thin profile and then I extrude it. By using the sheet metal, I just use this one. Sheet metal tabs has a base plans or tabs. Okay, you auto detect the square, and then I can use the gauge tables. Okay, I just browse for this first. Actually, inside the SolidWorks, there is a default gauge table. If you are familiar with the sheet metal industry, you will know what is gauge table. Actually, a gauge table is the gauge table is a very important. I just found from here. Yes, is that here? Sheet metal gauge table. Okay, so there's a lot of sheet metal gauge table. I choose samples, and then it's come out gauge 5, gauge 4, gauge 3. In this, actually, this is also a library. You can actually, all this is just the Excel file. I open the file for you as I opened just now. Okay, actually inside my program files, SolidWorks. Okay, SolidWorks files, lines. Okay, inside here, sheet metal gauge tables. This is this Excel file. Actually, this is inside the Excel file. Okay, actually you can build your own library like this. You can build your own radius or on what is the gauge angles, how many mm of every gauge, and then the radius of the bands, or you can calculate at here. You can see it here. You can input as here. Okay, and then this is the table. This is the Excel file. I opened the Excel file just now. Okay, I use the gauge 4, which is around 1.5 mm thickness, and then the radius I could give it 4 mm, very large. The band. Okay, then I click OK. Now the sheet metals will come out. The sheet metal product will come out. Okay, now I just make the material first. Same, I use the alloy steel. Now I use the stainless steel sheet flat first. Stainless steel sheet. Okay, now I want to make another sheet metal at here, assume bend at here. So I have an edge flange. I click here, and then you see that a flange will come out. Another sheet metal will come out. Okay, I bring it around 200 mm, and then like this. Done. You'll see here, it's come up another sheet metals. I already bent it. Okay, let's continue another sheet metal here. Okay, use the edge flange. This joint go up. I have even choose not only plane, can up to vertex and up to this vertex, and up to this vertex. Okay, then I can choose like this. Done. This is a very fast sheet metals. Okay, and then if now inside the sheet metal function here, we have the flatten. If I click flatten, it will flat into a one sheet. If here and here is the bend line for the sheet metal. If I deactivate the flattens functions, then it will come back again. Okay, now I want to use the weld corners to connect to weld these two parts. To weld these two ways. Okay, it's well already. Okay, so the next one is I want to mix the leeward here. I want to make a leeward here. So same just now. Inside the SolidWorks library, there's a forming tool. If I click the lures, there is a standard lure here. Actually, you can create your own forming tool. Let's say this lures, I just insert here, and then a lure will come out. Oh, sorry. If the lure is face inside, if I flip it, then it will go outside. You see, a lure has come out. I can make another lure here. It's quite easy to mix the forming tool here. The next one I want to make is I want to insert our CADVision logo inside. Same just now, I will see the CADVision here. If I open it, actually this is a normal part. You see, this is a normal part with all the words here, with the forming tool at here. And then now I close it first. I can simply drag inside here and then make the formings and mix the word here. Let's say this one I make to 180 degree, and then you see it will come out a form. It will come out something like a punch the words at here. You see the word is punched inside. Okay, the last one I want to mix the opening at here. So it's same as I will take using the punch tool. I drag my punch at here. Click OK. Then the opening will show up here. It's quite easy. Okay, even I can drag my logo. Let's say this one I drag to here. I just make the logos. I can drag it somewhere here. Okay, let's say this one, if I move it to around here. Okay, I move to here, I move to here, and then the walls forming tool will also follow it. Okay, you see, it changed the position already. Okay, now actually I still have to make another plate at here and at here, and then the top plate in order to complete the design. However, due to the time purpose, I will stop at here. Okay, so now let us just flatten the complete sheet metals. When I flatten it, okay, it takes some time. Okay, you see here, if I flatten it, it will show up the form is already formed here. All the form is come out, and then it's just like the bend and the welding. Actually, all the forming is done before the bending process. The punching process is done before the bending process. So this is the logic schema. Okay. As we done now we want to mix the drawing from these sheet metals products. So same as just now, we just save this part file, new sheets, new computer casing. And then I just need to make the drawing from it. Okay. If I have using the sheet metals, as you're inside the selections, front wheel, right wheel, side wheel, at the right side of the interface here, it pop up another new wheel called flattened wheel. This is the most important for the sheet metal industry. What are they make the drawings? They not make the front wheel, they not make the side wheels. What they make is they make the short drawings of the flattened wheel. Let my computer to load it first. Okay, I'll see here at the normal 3D models that only have top view, right view, front view, back view, left view, or other views as well. Now, if you are using the sheet metals function, it's pop up another new view called flat pattern view. If I drag the flat pattern view here, you'll come out the flat pattern view inside here. This is exactly what the sheet metal industrial wants. They are not using the top view or right view or something. They want this view. Okay, let's say this one, I just make it bigger. 1/3. Okay. You see the band line will also come out. Okay, now let's just make another current diametric views at here. Okay, these diametric views I would like to make it same as it's 1013. Okay, 8 color views. Okay, it's done. Now, since that I want to mix the dimension to it, so smooth it out, make the dimensions. Okay, come out some dimensions. And just make it better. Okay, 300, 700, all dimensions come out. Okay, so now I want to make the band table here because there is nothing information about the band here. So now, inside the insert tab, insert pull down menu here, at the table here, you come up a band table. I just double click it and then I click one of the model here. I select the flat patterns. Okay, then you see that. Oops, sorry, problems come out. And I just close the equals. Maybe there's some technical issue. Oops, sorry. Just the equals. What is this doing? The office. Okay. Never mind, I think I have to refresh. See that the file cannot be something cannot open. Clear minds, I make it bigger. Because just now it's possible to have a 4 mm radius. Okay, like this. See that there's no problem already. Okay, now I jump back to the drawing just now. Okay, I put back just now the drawings, and then I put the flattened view into the drawing. Okay, now I'll see here there's come up the icon of the banding. Okay, so now I use the custom of 1/2 scale. I use the custom of 1/2 scale. Okay, since 2 big, 1/3 is enough for you. Use custom. Nice. 2, 3. I have 146. Okay. Now this one, never mind, I just make another one with 1/3 on it. Patterns wheels with 1/3 of the scale. 1, 2, 3. Okay, this same okay. And then another, I make the trimetric views of 1, 3 or so. Sorry, I just repeat the thing I done just now. It's really color. And then now let's just make the bend, make the dimension first. Allow the software to arrange them well. Okay, so now just let us make the bend table. I choose the pattern view, and then you see that the table come up A and B. Tag A and B, and then here is A, and then here is B. You show the information of the bend. So this is how we create a sheet metal products by using the sheet metal functions inside the SolidWorks. Okay, so now this is the end of my presentation, my webinar sessions. So far, got any questions? So after you see these webinars, you have any questions, you can contact me by using these emails, johnsons@CADVisions.com, and my handphone number is this. You can contact me by using my emails or my contact numbers. Okay, thank you for attending my webinar sessions. Again, my name is Johnson Yaps. I'm application engineer from CADVision. So if any problems and any inquiry about the webinars, please contact me by the following contacts, emails, and contact numbers. Okay, so thank you.